The BritChips podcast is proudly sponsored by Silicon Catalyst UK. Hello, I'm Anthony Miller and welcome to the BritChips podcast, where I have conversations with movers and shakers in the UK semiconductor startup scene. I just do not believe anymore one can build a leading advanced computing startup in Europe. No, that's not what I believe, but it is the reason why my next guest is basically packing his bags and moving his startup to the US. He's Rodolfo Rosini, serial entrepreneur and now co-founder and CEO of his sixth deep tech startup, Vaire Computing. Now, Vaire, by the way, was among the first cohort in the government-sponsored ChipStart Semiconductor incubator, which is managed by Silicon Catalyst UK, our sponsor, and headed up by Sean Redmond, who Rodolfo mentions in the podcast. Now, you may be wondering, what's the point of the government incubating a UK startup for it only to up sticks and sail across the Atlantic? But before you pass judgment, just take a listen to what Rodolfo has to say. I'm sure you will find it both provocative and controversial. Rodolfo, welcome to the BritChips podcast, and let's get straight into it. The $64,000 question is, why does an entrepreneur who's founded 5 European deep tech startups, besides the other 2 that I know you've done, why do you say, and I quote what you said in your email to me, I just do not believe anymore one can build a leading advanced computing startup in Europe, and yet you've done it 5 times. Can we just start with that, Rodolfo? Because I help me understand why you think that.
Some of my companies were actually based in the US. So I would say not all companies were based where I live in Europe, so they're all originated here, but some actually ended up in the US, right?
Okay.
So first thing. And the second thing is, I think the issue is, let's call it activation cost, right? In software, you can build things organically. Or at least because we're in this transition phase, right? With CloudBot and everything. I think we have some sort of proto AGI, but let's assume we are a month ago, right? Before the sort of what's been happening right now. And in software, you can build very quickly a prototype. You can show it to customer. You can say, hey, this is the mock-up. This is how it would work. And usually it's something that's happening in the background on a database with a useful UI that shortcuts some of the workload that you do, right? Your work is sort of like at certain steps, and there is one step where it's very annoying to you, video editing or whatever, right? And I basically automate that step. And you're like, great, here's, $100 a month, right? And I start building these prototypes, and then it becomes more complex and everything. In chips, you cannot do that, right? In chips, you have staggering manufacturing costs and a very long design process, right? And so you can't find one customer, you can't build your customer base, right? You need some really big anchor customers that say that first of all, you have to prove this, right? And so you have to build some prototyping and already here, like the costs are debilitating. And then these customers say, okay, great, I'll anchor your production. I'll pay 70, 50%, whatever, of your equivalent of the manufacturing run, right?
Yeah.
And then you can go and find like smaller customers, maybe you don't have volumes. And therefore, this requires scale because no one really wants to build their own silicon unless they have to, right? Unless they have something. And that something usually comes with scale. If you're small, you just, there are a lot of vendors in the world that do some small stuff, right? But the when you need volumes because you need margins, that's where it matters, right? And I think Europe, for a long time, the value was in software, right? And all the VCs moved to software. All the think of like first the rise of the internet in the 90s, then the rise of mobiles in the 2010s, right? And companies didn't really scale, right? Europe is too fragmented. While the way we see it is it's a two-horse race, right? Between two-horse race, sorry, between China and
And the
the United
US.
States.
Yeah.
Right, and where they have scale, right, where they have these really large companies that say, oh, we need to be number one, we need to have. There is a direct link between how big the numbers you can crunch and how much money you can make, because the market is very responsive to automation, meaning that you can automate entire part of your business. You can lay off, 10,000 people, right, with very easily, right? Well, in Europe, to promote social cohesion, large companies are not allowed to invest in automation as much, as they're not allowed to scale. Right, everyone is allowed to scale within their own border, and then the moment if a French company tries to buy a German company, they're number one. Suddenly, everyone's like, oh no, but we can't have that, right? We have, I don't know how many bourses we have in so many stock exchanges, right? We have in Europe, right? And they're all like tiny, right?
Yeah, are you saying, Rodolfo, this is really a continental European problem, because you are one of so many ChipStart cohort members who are building and developing semiconductor technology here in the UK with a view to scaling up. And yeah, I hear this from them as well about the the incredible costs if you want to go get to silicon. But obviously there are many steps along the way, and some of them are building it, the prototypes on FPGAs. I've learned how to spell that now, on FPGAs. Others are using different methodologies, but I don't hear the same sort of concerns about scaling from the UK startups. Although, to be fair, there are those who are obviously eyeing the US market, and some taking money or will be looking to take money from the US. So I mean, you're in the UK, you're a ChipStart cohort member. Do you really think then that you can't do this in the UK?
I believe so. Sorry, let me. The margins of success are so tiny, right, that you're really trading on these small bumps, right? And the 1% chance of improving here, 1% chance of improving there. It's sort of, you stack them up, and sort of like that sort of makes you successful versus unsuccessful. And in technology, it's really a zero-sum game, right? There is a winner takes all. Like in the beginning, you can have this massive market, and but everything, when you really, really reach the leading thing, there is one competitor that really takes everything. Look at, or one or two, right? Look at phones, whether an iPhone, look at operating systems, look at desktop, look at AI chips, and so forth, right? It's because it becomes an R&D scale game.
Yeah.
And so
But
if you really want to...
let me, sorry to interrupt. Let me just, because you said it was a winner takes all game, and okay, you can see that obviously with your Metas and with your Amazons and whatevers, but there is still room, surely, for the number twos and number threes, the number fours. Can't they still be scale companies? Okay, they may not be the market leader, they may not be the dominant one, but there must be room in the market for others, isn't there?
In software, yes, it is, and so you see this sort of ecosystem being formed. I think in hardware, the feedback cycles are so extreme, right, that I don't think there is, who is number two in the AI chip space. Number one is 94% of the market. Number two is 6% of the market, AMD, right? And they don't have pricing power. They have to discount their products. Number three is Intel, is 0%. And so you can see that there is no gentle slope, right, on to be number two, number three, because in software you can stop your R&D and just leave off the previous gains. Right? You just, like, provided you pay your cloud computing and you keep supplying product to your customer doesn't really care if your product doesn't get improved, right? They just want it to work, right?
Yeah.
And so you can, I mean, Adobe Photoshop, right? I don't think has been updated in 30 years, right? Give or take, right? It's the same product, right? And But chips, you basically have to redo the entire chip every 2, 3 years, right? And so you cannot survive by starting. I don't believe that you can build a successful company without the explicit aim of being number one, right? I think that's the issue for me.
Well, I think that's a terrific ambition, not one that I've heard voiced by other startups, but of course they are early in the piece, and very few of them, in fact, none of them, and certainly none of the university-based founders that I've spoken to have already launched 5D startups. So obviously you're much further along the path. So when it comes then to, I should have asked you before, how do you pronounce your company name? Is it Vaire or Vaire?
Vaire.
Vaire.
Vaire. Unless you speak Finnish, in which case people that speak Finnish, they will be able to pronounce it perfectly, but everyone else, you can't pronounce it there.
In that case, you better tell me, for an Italian, tell me why you're using a Finnish word, and what does it mean?
It's from the Silmarillion from Tolkien. It's one of the characters from the Silmarillion. There is this
From the Silmarillion.
trend started by Peter Thiel of naming companies after Lord of the Rings and Professor Tolkien's Legendarium, right? And all the major characters and major events were already taken, and I ended up taking a super minor character, but the domain name was like $10, and turned out to be the goddess of weaving, which I felt it was appropriate because the Jacquard loom, I think, was the first programmable computer or this programmable thing, right? So yeah.
Well, I think you probably get the prize for one of the most obscure company names and sources that I've spoken to, but I like it. I like particularly the Jacquard loom, the allusion to the Jacquard loom, because I've got to be honest, and obviously I've looked at the website and done a bit of research, and while I conceptually get what you're trying to do, when I first read it and reread it, I thought, is this guy basically trying to create a perpetual motion machine in a chip? Because it just, I thought, well, that does sound like Mission Impossible. And I've looked at the pictures and the explanation. I said, in concept, I kind of understand, and you use the term reversible computing. It just, to me, and obviously I'm not a semiconductor technologist, but I am, reasonably technical, and the idea of, you're doing computations both ways, and therefore you use virtually zero energy. I can't conceptualize that. It's beyond my pay grade. Is it possible to explain, to someone like me who is technically inclined, but clearly not down at this level, the sort of the idea behind this?
Of course, but it's actually not that complex, and it's not a perpetual motion machine. It's more like a Toyota Prius, right? That's sort of like the concept of regenerative braking in Toyotas is sort of like kind of similar conceptually. The idea is this: you have transistors switching in a chip, right? And every time they switch, they dump their energy to the ground, right? Every time. You multiply this by 1 billion transistors switching 1,000 times a second, and suddenly, like, this majority of the heat that you're generating on the chip, right?
So, and this was the point I think you make in your various write-ups, that most of the energy in a chip is dissipated as heat, not as useful work. Is that the bottom line?
Correct. And the reason why you do this is because although transistors you could use a very, very small amount of energy to actually change the state of a gate, there is a threshold that is way, way higher that we use, because otherwise the transistors just start switching on their own, right? And basically just the background noise starts affecting heat starts affecting a chip, right? So you keep this threshold super high, right? But then you dump it all into the ground, right? For no good reason, right? I mean, the good reason is that's the best way to make a chip go faster. Right? So
Can I
if you
just
care
make sure
about
I understand that? Because I think I kind of get it. You're saying that the actual amount of energy needed to switch a transistor is very small, but unless you set a gate high enough, it will start switching sort of because of the background sort of electrical noise
correct.
in the chip, and therefore the difference between the energy you need to actually do the switching and the actual threshold energy that the higher voltage that you need to make sure that it's not affected by noise, that difference is wasted energy. That's
Correct.
yeah.
That is correct, right?
Now you're recycling that.
Correct.
How does that work?
So every time, because there is a dissipation, right? And when you charge the gate and when you switch the state of the gate, right? And so what we do is every few gates we have a resonator, which is a glorified name for a piece of metal, right? That can store and take the charge from electrical to magnetic, right? Store it for a brief period of time and then send it back the circuit, right? So this is not new, right? There's been chips that have been doing this for a while. What no one has done this before is that there is the sending back part. Basically, what was happening, what people tried is, okay, can we dump this and store it and then somehow or distribute this into the clocking scheme, right? And this is not particularly efficient, right? What we started doing that if you actually build an architecture that is reversible, meaning that the computation can go backwards, you can actually send back via the same channel, right? And which makes it much more efficient.
This was the bit I didn't understand. Forgive me for interrupting again. Is doing kind of the reversible computation, because you've got your little picture there of your gate and the inputs going in, and out comes the output. Get that? Yeah, I do remember that from my university days. But then you say at the same time you can be going backwards. Is that real? Or have I completely lost the plot?
Yeah. No, it's correct. But essentially, it is rather than maybe because reversible computing can it's a wider field, right? And we do adiabatic reversible computing. It's just a smaller one. Rather than thinking of computation going backwards, think of it. You change the state of a gate, and then we reset the gate using the same energy, right? So you do a recompute, and then you go back and you reset the gate, and that charge goes back, and then you can reuse it for the next computation, right? Just not all. Basically, that's and you don't. It's not the entire system is reversible all the time. What you do is something called Bennett clocking, where you do between 10 and 100 operations, and you copy the answer, and then you recover all the energy by resetting all these gates, right?
So is the issue then that you've got that you just can't get enough believers with money who to fund you with the development of your technology?
I mean, verse. I think it sounds how can I say? Sounds that the burden is on other people rather than on me. Right? I think it's more we built this as a contrarian bet.
Right.
And the reason why we built this as a contrarian bet is because if you look at the market for unconventional computing, there is a whole spectrum, right, of probabilistic analog, quantum, photonics, and like there's entire thing, right? And then you pass a certain threshold, and then suddenly you are in the world of orphan technologies, right? Where there isn't a single company for this. There are things like ternary or there are a bunch of these, right? And we picked one that did not have the market did not exist, right? Which is very, very hard from a VC perspective, right? To get conviction on. Because if there are no customers, so if there are no companies, means there are no customers, there's no market. Building a market from scratch is very, very hard, right? However, right, I believe that in venture, the way you make money is you have to be contrarian and you have to be right? And so there is no point building the nth AI accelerator doing exactly the same thing as NVIDIA. because in what we're doing, we could become part of the ecosystem of NVIDIA, we could become a partner of NVIDIA, we could become a supplier of NVIDIA or whatever. We could simply operate in the market that NVIDIA considers too small, right? But if you're trying to do the same thing as NVIDIA and you're hoping to outperform them consistently, I think it's a very different bet, right? Grok, it took them 10 years more before being taken out, right? Was a great exit, right? But they struggled for a very long time, right? So I don't know, right? I think it's an issue of what I was mentioning before, scale. There is this entire pipeline, right? So it's difficult to go public. There is no M&A, and the reason why there is no M&A is because all the public markets in Europe tend to be in service of a welfare state, so they prefer mature stocks that pay dividend versus growth stocks. Right?
Yeah.
Because people are not in charge of their own portfolio. If people were in charge of their own portfolio, you could see a lot of people that allocating smartly money. VCs struggle to raise funding. The family offices in the UK are in Europe, right? And this is not a UK problem, right? And it's a European old world problem.
Yeah.
Family offices where the wealth creator is dead at this point, and so you don't have the someone that wants to maximize the wealth, right? You have a family of cousins and grand cousins that want to maximize their checks at the end of the month, right? And so this you see allocation in real estate and stuff that's profitable. So not deep tech, not R&D cycles, right? You don't have university endowments, right? You don't have these foundations. So the structural, I mean, you have some, right? But it's not really at the same scale, right? And so there is in every problem you have friction, right? And then what do you do? Well, you either swim against the current, and I just don't think you can do that, or you wait until, or you pick an easier problem like software or B2B SaaS or whatever. I believe that the solution is elsewhere. And by the way, this is not, there is a fractality in this narrative that this is happening on my company, but I think it should happen at a country level, right? I think the UK should align itself as much as possible with the US to benefit from this economy, right? You might not want to, for whatever reason, copy the American society, right? And,
I think there'd be a few who might agree with that. Yeah.
Now I pledge the fifth here, but definitely we should be copying the economy, right? Because that is the one thing that they have that is, it's the greatest economy in the history of humanity, right? And like, I don't think there's anyone who created as much wealth as they have. So there's no point trying not to be that, right? We should all be that, right?
I get the point, but let me just come back to your technology, because I understand this is a contrarian bet. I mean, you do have funding. I noticed you had was it about 4 million?
10. We are 10 million.
10 million now.
First. Okay. 10 million. We had a first close, the second close, and so a lot of people reported the first close only, but we actually raised 10 million total.
Oh, congratulations! I could only find record of the 4 million and the previous 500 in grant, but that's great. So you clearly have
no grant. We never had a grant.
Okay, just goes to show. Don't believe. Yep.
We're unique in this, that we have no direct funding from any agency in the US and the UK. We have standard R&D credits. Yeah. We have, of course, part of ChipStart.
Yeah.
From Silicon Catalyst, but we don't have direct funding.
Setting that to one side, you said earlier in our chat that this idea of reversible computing, adiabatic, is not new in itself. So does it not worry you that if the theory and the concept is well known, that no one else has managed to do what you're trying to do? The reason there is no market is because it can't be done.
So there are two things, right, to this, right? So the first one is that, just to refute the argument at a very high level, quantum computers are reversible. And so I'm not so sure why people don't believe that that people believe they could do reversible computing in a quantum space, but you cannot do it on CMOS, right? And so that's sort of like it's an argument that I think it's there's a bit of a fallacy here, right? But then from a more practical perspective, the reason was not technical, was an issue of economics. When they built the first chip in the 90s, there was the reversible chips are really bad for single core performance, stuff like CPUs. That's really not the fit, right? And so in the 90s, the market was CPUs. There was no market for parallel computing, right? Beyond scientific applications. There was no mass market, no enterprise market. You have a lot of these like supercomputing companies, like thinking machines in the 90s, right? That sort of, they all went belly up because there wasn't really a market, right? These are the guys that built like a GPU the size of a cabinet, right? The reason why this matters is because parallel computing went from a curiosity to a gaming hobbyist thing to the most valuable workload, right, today with artificial intelligence.
Mm-hmm.
So the market moved on to something valuable, right? And so you could spend hundreds of millions of dollars in the 90s to solve this technology, but still you couldn't build the company, right? So the issue is the timing and the fact that as long as Moore's law would continue, there's no need for reversible computing, right? Richard Feynman talks about this in the 80s, specifically says like, why would you want to do reversible computing? It makes no sense, right? As long as you can keep getting gains for classical, there's no point complicating, right? And our point is that, okay, well, classical is over, right? It's the generation of chips that are in development now are the last generation, right? And you really see this happening at with sort of a scale up with a wafer sized product, right? Sort of like first you would shrink the node size, and now the wafer the chip is getting bigger, right? The system is getting bigger, and I think we're a couple of years away from Moore's law being functionally dead. Even though we can continue the transistor scaling for a decade, what happens is we have to slow down the clock speed of these transistors. The other thing is that there was a breakthrough in 2023. So before we started in 2021,
Right.
in 2021, technology did not work. There was a component missing. San Diego National Lab solved that in 2023. Nobody really paid attention. Basically, in 2023, the technology was solved, right? You could build it, just had to build it to prove whether it was true.
Yeah.
And that's what we did, right? So we proved it at the transistor level, that sort of the gate level that it works. Now we need to prove that the system level this works, right? And then basically once we've done that's sort of, I mean, that's it, right?
And how long is that going to take you? Say you've proven it at the gate level, what, on silicon or by simulation or FPGA?
No, on silicon. We've improved it in silicon, right? Because of course, like if we done a simulation, everyone would be like, oh, but simulations and improve in silicon, right? And in silicon, there is some, again, this is not magic technology, right? It's more, there are some trade-offs, right? And so the trade-offs like this requires a larger area. A trade-offs that this requires a streaming workload, right? If you do this on a workload that's intermittent, you end up using way more energy, right? Than normal. But if you use a streaming workload, you unlock these efficiencies. So everything like image processing or token, basically streaming token generation.
Yeah. Okay.
This is a good fit.
But you said you said you've raised so far 10 million. How far will that take you in the ongoing development, do you think?
Not very far. We'll be out raising soon. And building, because building silicon is expensive. Building silicon and researching a new computer architecture is very expensive. And we're the only one working on this at this point, right? So there's no, we don't get the uplift of 10 other labs doing stuff for free in academia, right? And so everything we do ourselves. So I would say the story of silicon is burning.
Yeah.
Piles of cash and then sort of praying to the gods and hoping something happens, right?
How much do you need then? You said you go, if you're able to talk about it publicly, how much are you looking for?
I think if you look at the entirety of R&D, which does not include equity money, and consider the dynamo cycle of of this, it's more you raise some money and you get customers order, and then you sell the chip, and then sort of all the profits go into into the next R&D, right?
Yeah.
Rather than venture, because venture capital cannot really, it's not really designed to, you can underwrite software R&D again, right? Because it's organic, but really hardware
Sure, you
R&D,
want to
you can't
generate
float on
cash
venture
flow
capital.
to fund your business.
Yeah, so we think it's about $300 million, right? to
300 million. Okay, and this is why you're looking to the US rather than to European or UK VCs. Is that what you're saying?
Yeah, I mean, but not just VC. VCs are sort of, VC will come from anywhere, right? The problem is there are no customers, right? There isn't really I mean, who's the biggest buyer of chips in Europe? I have no idea, right? Maybe some automotive companies that's buying chips from Infineon, right? But I'm not really sure about the scale. The hyperscalers do not exist in Europe. They're all American, right?
So what's your plan?
So we are going to release the system level performance dev kits this year,
Right.
and yeah, that's all. We're already talking to customers. We're already giving them sort of the expected performance. The next step is going to be giving them, okay, well, this is like the most accurate performance, and then sort of having the ability to simulate workloads, right? That sort of meet this year, where you can actually run your workload and you can see how efficient it is, right?
And the customer interest is what, only in the US?
Yeah. We sort of talked. Because we didn't know, right? This is a new market for everyone.
You're breaking ground.
No one has bought or exactly. So, let's talk to everyone in the Middle East and in Europe and Asia and it just basically there are two markets.
Even
There's
Asia.
China and the US.
Even, I mean, you mentioned you weren't getting any response from Asia.
No, we did.
Sorry, I misunderstood. Sorry.
No, we did.
Yeah.
But the problem there are two markets, China and the US.
Right.
We sort of picked our you pick your battles.
Yeah,
right?
Thank you for that.
Yeah, but there is no one else, right? And
Okay.
everyone else is not willing to shoulder the R&D cost because they don't have the scale, and therefore they don't need to kick in the efficiency by having their own silicon, right? So let me give you another example, right?
Yeah.
What are the major space companies, right, and that are looking to build orbital data centers, right, in Europe? I don't think there is anyone meaningful that has done. I mean, and ironically, the largest one in the US was funded by a guy, South African, Canadian, so clearly Commonwealth, right? The largest startup was funded by a guy from London, right? And it's in Seattle, right? And so, but they're not here, right? Because the capital is not here, because the defense spending is not here, right? And yeah. So that's sort of like, so for us commercially, we are very much in the US orbit.
So basically, well, when will you move across to the US and in effect close down your operation here, do you think?
We already closed our offices last week.
Okay. So. And you'll personally move across to the States?
I'm considering, right? This my co-founder Hannah already moved.
Oh, of course, Hannah is already there. Yes, your co-founder.
She's already there, and this is another example. Hannah is a brilliant, and not because she's my co-founder, like objectively brilliant physics graduate from Cambridge. Did her undergrad, her master's, a PhD at Cambridge, right? And he's someone that you would consider sort of like a top tier talent, and she already has a green card, right? And she makes there way more than she could have made possibly in Europe, right? And so this belief that people do not respond to incentives, right, and economic incentives, I think it's a very dangerous trap, right? And because of course you don't do this because of money. Like if all of us wanted to do something, we would be doing investment banking, right?
Yeah.
We would be basically managing money or be fund managers, right? No, so we do this because we have a passion for what we do. We care about building products or.
No, I totally get that. This is why I do what I do, because I love doing it. Yeah, but that's
correct, right?
Yeah, that's no.
But expecting, but then having high taxes or demonizing entrepreneurship or just. And by the way, California is the same, right? I'm not saying that the UK is unique, right, on this, right?
Okay, I'm not entirely sure I would agree with some of your assessments, but they're your views, your opinions, your experiences, and there's probably a whole other podcast so we can discuss that. But I do want to just quickly talk about before we finish ChipStart, because did you get anything out of the ChipStart program?
Oh, absolutely, absolutely. I would say that there are two companies, right? The one before ChipStart, so and one after ChipStart was transformational for us. But here's the funny part: do you know how it was transformational? Because they found us a mentor from the Bay Area. So that was like for us was he opened up all these contacts and everything, right? That was the I would say the fundamental. Everything else that they did here was useful because again, there are no customers, right? And so it's not that suddenly you have the UK government said, "Oh, great, we have all these like, we need to build all these drones, we need to build all this stuff," like just complete lack of budget, right? And again, not lack of willpower, right? And it's mostly like it's not considered strategic industry is not considered a priority. Crunching numbers is not considered important. And so apart from a couple of people from the city, there is nothing here, right? So but I was a big fan of ChipStart, and like you, I was very skeptical that like how are you going to find 2 or 3 companies for a cohort, and then turns out Sean found like 10 every time, and they were not bad, right? And successful, you create this sort of like fertilizing layer of dead startups, right? To then create the next, right?
It's a proverbial virtual circle-y thing, whatever you call it. Maybe that's not quite the right analogy, but they're now in the middle of cohort 3 and recruiting for cohort 4, and I'm just so both surprised and delighted that there is this sort of groundswell of really entrepreneurialism and innovation, mostly coming out of the universities. And it's just a relatively small number that do this, but now there's the opportunity for someone to help them commercialize, which is really what it's all about. But I do wish you all the very, very best with it, because it sounds the most exciting thing.
Well, look, as I said, left field. Don't tell me the odds, because I know the odds, and the odds are not in my favor, right? And let's see, right? It's either I'm right or I'm wrong, right? And if I'm wrong,
you've got to try. You've got to try. Yeah,
I'll do something else. But I think we're after 5 years in. I think we are correct. Right, and now just need to be able to prove it, right? But thank you.
Okay. Rodolfo Rosini, co-founder and CEO of Vaire Computing. Thank you very much indeed for joining me on the BritChips podcast. Thank you. Okay.